It ran perfectly on our machine. Ship it. We're heroes.
Did you deploy 20 seconds ago?
Yeah, and it's been flawless.
Oh man, production is on fire.
What? Production's just jealous of our deployment.
The code didn't change between my laptop and that server. Not one line. So why did it break the second it got deployed? The four most expensive words in software industry are works on my machine. By the end of this, you'll know exactly what it is and why it was never really the code. This is Sticks It Out.
I swear, it really works on my machine.
Here's the thing nobody says out loud. Your code doesn't run on your code. It runs on your machine. And a machine is not just the file you wrote. It's a runtime, some secrets, a set of assumptions, all the stuff your code quietly leans on without mentioning it.
The code is the code. Copy the file over, it does the same thing. Servers don't matter.
That right there is the mistake that wakes people at 2 a.m. Think of your code as a recipe. The recipe works in your kitchen. Someone else runs the exact same recipe in their kitchen, and it comes out wrong. The recipe didn't change, the kitchen did. Works on my machine just means works in my kitchen. So let's walk into the kitchen and find everything your recipe assumed was already there. First thing your recipe assumes is the oven. In software, the oven is the runtime, the thing that actually executes your code. You wrote C# for .NET 8. Your laptop has .NET 8. The server is still on .NET 6. Same recipe, older oven, different result.
So it's like just 10% off. Close enough. It'll cook.
It's not just 10% off. Some features you use from .NET 8 don't exist in .NET 6. So the moment your code reaches that part, it throws an error at runtime. The oven's missing a burner, and you find out mid-bake. And it's sneakier than versions. On your laptop, you ran a debug build, extra checks, friendly errors. Production runs a release build, optimized, stripped down. Same source, two different programs.
Why would the same code become two programs? Pick one.
Because the code isn't the program. The code plus the runtime plus the build settings is the program. Change any of those, and you shipped something you never actually ran. Next thing your recipe assumes is the pantry. Your code depends on other people's code like libraries, tools, packages, etc. That's the pantry it cooks from. Your laptop's pantry is stocked. You've been installing things on this laptop for a year. Some of it your project needs and never wrote down in the deployment document.
If my project needs it, it's in my project. Obviously.
Are you sure about that? You installed a tool globally 6 months ago. Your code uses it. It's not in the project. It's just on your machine. Prod is a brand new empty pantry. It's never heard of your tool. Remember the runtime from a second ago? Same trap, one layer out. Your machine has history. Production has none. It starts from nothing, every single time.
So I just install everything on prod too. One time. Done forever.
Until the next server, or the next teammate, or next week when you ship an update that needs a new library. Same server, but it's never heard of that one either. Install everything by hand and hope isn't a plan. It's the thing we're trying to kill. Okay, same oven, same pantry, and it still breaks. This next layer is the one people usually mean when they say it broke. Your code reads settings from outside itself. Where's the database? What's the password? Which features are on? Those answers aren't in the code, they're in the environment.
My connection string works fine. I can see the database right now.
You can see your database, but your connection string points at localhost, and that's nothing but your machine. In production, localhost is the production server, which has no such database. Same word, different place. This is where the recipe metaphor makes sense. Your recipe says, add the sauce from the fridge. Your fridge has the sauce. Prod's fridge is empty, or the sauce is behind a locked door you don't have the key to.
So the code is lying about where things are.
The code isn't lying. It's asking the environment a question, and the environment gives a different answer in every kitchen. That's the point. You just have to give prod the right answers. Last layer, the floor itself, the operating system your code stands on. You develop on Windows. Production is Linux, in a container. And Linux cares about things Windows shrugs off. On your Windows machine, logo.png and logo.png are the same file. On the Linux server, they are two different files and one of them does not exist. Your image is gone and you changed nothing.
Nobody would name a file that carelessly.
Everybody names files that carelessly. Capital letters, backslashes and paths, the time zone your machine is set to. All of it is the ground you didn't know you were standing on. And one more, the data. Your app works because there's a test user in your local database. That user only exists on your machine. Prod's database never met them. The code runs, the data underneath it is a different world.
So even the floor and the fridge are against me.
The floor was never on your side. It was just quiet on your machine because you happened to match it by accident. Step back and look at the whole diagram. The little file in the middle, your code, is identical on both sides. Everything wrapped around it is different. The runtime, the dependencies, the config, the operating system, and its data. That whole stack around your code has a name. It's the environment. Works on my machine means works in my environment, and you are only ever testing one of them. So the fix isn't to test harder on your laptop. It's to make the two environments match. Ship the kitchen, not just the recipe. That is the entire reason containers exist. A container packs your code plus the runtime, the dependencies, and the config into one sealed box. You run that same box on your laptop and in prod. Now both kitchens are identical because they're literally the same box. This week, find one thing your app assumes about its environment that isn't written down in the repo. A tool you installed, a path, a setting. That thing is your next 2 a.m. wake-up call. And before you think containers end this forever, they don't. A container still borrows the core of the machine it runs on. On a Linux server, that's the server itself. On your Windows or Mac laptop, Docker quietly runs a tiny Linux machine inside, and the container borrows from that. So an image built for one type of chip may still misbehave on another. And if your base image says latest, 2 builds a week apart can quietly pull different foundations. Containers make your environment reproducible. They do not make it identical to the laws of physics.
Got it. I'll put everything in a container and never think again.
That's the opposite of the lesson.
So now it breaks the exact same way everywhere. No more surprises. I call that a win.
If you're wondering how prod runs 10 of these identical boxes at once without them fighting, that's orchestration, and that's the next video. This has been Sticks It Out. Don't let your brain deploy on a Friday.